Hey everyone, my name is Nick Van Nest. I'm a developer advocate here at Unstructured. Today I'm going to walk you through a short intro to our platform and then dive right into a demo. You'll learn how to go from your file storage solution like AWS S3, process your documents using Unstructured, and deposit the structured outputs in a Qdrant database. Let's start with the fundamental problem. Most Gen AI initiatives rely on structured data, but in reality, 80% of enterprise information lives in unstructured files. Things like PDFs, Word docs, emails. This data is valuable, but it's incredibly hard to work with in its raw form. Here's what it typically looks like trying to process unstructured content. You wind up compiling together custom scripts, third-party tools, and open-source libraries, all duct-taped together in something barely manageable. We call this a rat's nest, and it breaks easily at scale, takes a large amount of engineering resources, and often fails on several use cases. Unstructured solves this with a composable platform that handles this mess for you. From connecting to sources to transforming documents to delivering outputs downstream, it supports 35 plus source connectors and 50 plus file types and integrates with modern databases like Qdrant. We offer multiple transformation strategies depending on the complexity of your files, from basic text to documents to scanned images and handwritten content. The output can be structured JSON with enriched metadata and vector embeddings. Our parsing approach is dramatically more efficient than alternatives, so whether you're processing 1,000 or 100 million pages, Unstructured lowers your total cost of preparation. Here we're going to transition into our demo and show you how this whole system works. Let's walk through the end-to-end demo workflow that connects S3, Unstructured, and Qdrant. This is a typical architecture for turning unstructured documents into vectorized data for search, retrieval, or Gen AI applications. We start with AWS S3. This is where raw content lives. PDFs, Word documents, PowerPoints, web pages, all stored in a bucket. For our purposes, we are uploading a PDF document to S3 and then making that available for this workflow. Unstructured's S3 connector pulls documents from AWS S3 and deposits them in the Unstructured SaaS platform. No manual file handling required and no custom code. We partition the documents into structured elements: titles, tables, body text, images, all layout aware. We then chunk those elements into segments designed for large language models and retrieval using title-based, similarity-based, or custom chunking strategies. Then, we embed those chunks, turning them into dense vector representations. We use the Qdrant connector to deposit the data into a Qdrant vector database for easy storage. Now your data is ready for semantic search, RAG pipelines, or agent-based querying. So from S3 to vector database, this entire flow is handled by modular, unstructured components. It's scalable, composable, and it's optimized for enterprise workloads. This is how Unstructured bridges traditional content with modern AI systems, securely, efficiently, and fast. Now let's walk through the actual implementation. First, we configure our environment. This notebook contains a series of instructions to pull all of the information you need to set up your environment correctly. For this notebook, we require AWS credentials for S3 access, an unstructured API key, and Qdrant Cloud credentials. Unstructured securely manages these credentials with enterprise-grade security. Let me run the configuration cells. For this portion of the notebook, I've defined several different functions that will help us run our workflow. These are all annotated and available for review, so feel free to look at this notebook later and understand how the Python SDKs for Unstructured and Qdrant are being used. Under the main pipeline execution section of our code, we start by downloading sample PDFs and uploading them to S3. In production, your documents would already be in S3 and readily available for your pipeline. I'll execute the download and upload cells. You can see that we've successfully downloaded the file and then uploaded it to S3. Now we create our connectors. This is where Unstructured's connectivity really shines. Let me run the S3 connector creation. This connector is configured to recursively scan our S3 bucket. It handles authentication and file discovery automatically. Now I'll run the Qdrant connector creation. This automatically stores process results as vector points. It handles batch optimization for performance. Once created, these connectors are available in the Unstructured platform and can be reused across multiple workflows to receive or deposit data. Here we will be building the workflow. This is where Unstructured composability really shines. We're building a custom workflow with 3 nodes that work together. Let me execute the workflow creation now. After running create workflow, you can see individual nodes of our workflow. Node 1 is the VLM partitioner. It uses GPT-4o vision for intelligent document understanding. It recognizes document layout, tables, images, and text hierarchy. This goes beyond simple text extraction to understand document structure and preserve important context. Node 2 is the smart chunker. It uses chunk by title strategy for semantic coherence. We get 1500 to 2048 character chunks optimized for embeddings with structure-aware splitting. Node 3 is the vector embedder. It uses OpenAI's Text Embedding 3 small model. This creates embeddings that understand semantic meaning for better search results. This composability means you can mix and match processing nodes for any use case. Running the workflow returns a job ID for tracking. Unstructured provides comprehensive job monitoring. We get real-time status updates and progress through each workflow node. Here, when I run the polling function, I can show you status updates. This monitoring is crucial for production deployments, especially at large scale. Let's verify our process documents in Qdrant Cloud. I'll execute the verification functions. Here we can see that the pipeline completed successfully, and that for one file uploaded to S3, we retrieved 43 points in Qdrant. This is the result of our chunking function. Here we can retrieve and display sample data. Of the 43 points in the collection, we've retrieved 3 different points. We can see that the dimensions are 1536 for the vector. Notice how Unstructured preserves rich metadata. We have document hierarchy and structure, element classification like title, narrative, text, and table. So for example, we have a composite element, which is the element type, in addition to a list of all the metadata provided. And we even have a sample of the text that had been chunked. With our documents now processed through Unstructured, we have enhanced retrieval with semantic search capabilities. This enables more accurate AI applications that can find relevant information and provide proper citations. We also have a production-ready pipeline with enterprise security and compliance. This system scales automatically, whether you're processing 10 documents or 10 million. Plus, we have a composable architecture that's easy to modify and extend. You can add new capabilities without rebuilding your entire pipeline. With this demo, you have what you need to remove the rat's nest of ETL when transforming large amounts of documents. Thank you so much for taking time to learn about our platform. We have a lot of different tutorials that you can use to integrate Unstructured into your workflows. To find them, visit docs.unstructured.io. Thank you.